Hello, this is MEI Further Maths Core Pure. We're in the third matrices section and on the second video on the inverse and determinant of 2 by 2 matrices. You can watch the video straight through, but you will probably find it helpful sometimes to pause the video and try things out for yourself before continuing to watch. In the last video, we found the inverse of this matrix T. For any matrix ABCD, the value of AD minus BC is called the determinant of the matrix. For T, we see that AD minus BC is equal to 8 take away 3, which is 5. And that gives us the denominator of the fraction in T inverse. You can also see that the values in the cells A and D have been swapped, and the ones in B and C have become negative. This is true in all cases. You can check this by multiplying the general matrix ABCD by this inverse both ways round. You'll find that you get the identity both times. It's also an interesting exercise which you can try to find the inverse of the general matrix using the simultaneous equations method from the last video. But for the exam, you just need to remember this formula. The determinant of a matrix is just a number, and that number might be positive, negative, or 0. For example, for the matrix 1, 4, 2, 8, AD minus BC is equal to 1 times 8, take away 2 times 4, which is 8 take away 8, or 0. And remember that the determinant only exists for square matrices. Here's some notation with which you need to be familiar. Now pause the video for a moment while you work out the determinant of these three matrices. OK, the determinant of A is equal to 2 times 4, which is 8, take away 5 times minus 1, or plus 5, which is 13. The determinant of B is equal to 2 times minus 4, which is minus 8, take away 1 times minus 3, so that's plus 3, which is minus 5. And the determinant of C is equal to minus 3 times 22, which is minus 66, take away 7 nines, which is 63, giving minus 129. Let's now put this with the swapping entries round to find the inverse. So, for this matrix M, M inverse is equal to 1 over 3 times minus 7 is minus 21, take away 8 times minus 4, so that's plus 32. And then swap the 3 and the minus 7 and change the signs of the minus 4 and the 8. And that's answer C. Notice that the other multiple choice options are all the common mistakes. So in B, they've made an error with the signs in the determinant and got 21 add 32 instead of minus 21 add 32. In D, they've forgotten to divide by the determinant altogether. And in A, they've got the determinant right and dividing by it. They've swapped A and D, but they've forgotten to put the sign change in. There are several steps here, and you need to make sure you remember to do all of them. If the determinant of a matrix is 0, then the inverse matrix doesn't exist, and the matrix is said to be singular. It doesn't have a partner inverse matrix. So in this example, we're asked to find K, and we're told that the matrix is singular. That means that its determinant, 3 plus K, multiplied by 2 minus K, take away 3 times minus 2, which is then plus 6, is equal to 0. That gives us 6 minus k squared plus 6 equals 0, which is k squared plus k minus 12 equals 0, which gives us k plus 4, k minus 3 equals 0, and therefore k is either minus 4 or 3. You need to know how to find the determinant of a matrix on your calculator, so do take some time to check that. If it's a straightforward numerical example, there won't be any method marks. But you also need to be able to do it by hand in case they've put any algebra in, when your calculator won't be any use. If the determinant is not 0, then we do have an inverse, and the matrix is said to be non-singular. Pause the video for a moment while you try this question. OK, we're told that the determinant of this matrix is 2. So x minus 2 times x minus 1, take away minus 1 times minus 4, so take away 4, is equal to 2. So that's x squared minus 3x plus 2 minus 4 equals 2, or x squared minus 3x minus 4 equals 0. Then we have x minus 4 times x plus 1 equals 0, and x is equal to 4 or minus 1. There are a couple of useful results about inverses and determinants which you need to know. The first one is how to find the inverse of the matrix product AB. We'll start by giving it a name. Let's say x is the inverse of AB. So we know that x multiplied by AB is equal to the identity matrix I. First we're going to post multiply by B inverse. That's x AB multiplied by B inverse equals I B inverse. Because matrix multiplication is associative, we can re-bracket it like this. And on the right hand side we know that multiplying by the identity makes no difference, so we've just got B inverse. On the left, B times B inverse is I, and we've got XA multiplied by I. And of course multiplying by I makes no difference, so we've got XA equals B inverse. Now we post multiply by A inverse, and we get XA multiplied by A inverse is equal to B inverse A inverse. Rebracketing, and then we know that A inverse is the identity, and multiplying by the identity makes no difference. So now we have this useful and important result, that the inverse of AB is equal to B inverse A inverse. You can check this by multiplying AB by B inverse A inverse and checking that you do get the identity matrix. The second important result is to notice that the determinant of AB is equal to the determinant of A multiplied by the determinant of B. I'm not going to prove this, but we will just check it for a numerical example. So here the determinant of A is equal to 2 times 4 is 8, take away minus 5, which is 13. The determinant of B is 8, take away minus 3, which is 11. So that the determinant of A multiplied by the determinant of B is 13 times 11, which is 143. Now we'll find the matrix AB. Which is equal to 4 add 5, which is 9, minus 6 add 20 is 14, minus 2 add 4 is 2, and 3 add 16 is 19. The determinant of AB is then 9 times 19, take away 2 times 14, and that's 171 minus 28, which is 143. So we can see that that result holds for these two matrices. There are more notes on integral or in your textbook on the inverse and determinant of 2 by 2 matrices. That's the end of this short video. The next video in the series is on the inverse and determinant of 3 by 3 matrices.